Welcome. A few students have sent me emails about this particular problem from section 6.3, so I want to go ahead and work through this particular problem. A random sample of n equals 100 observations is selected from a population with mean 29 and standard deviation 24. So the first question is, what is the mean for x bar? Okay. And what is the standard deviation for x bar? Remember that x bar is just a symbol for the sample mean. Now remember, using the central limit theorem, we know automatically that the mean for x bar is equal to the population mean. And here the population mean is 29. We know also from the central limit theorem that the standard deviation for x bar is equal to the population standard deviation divided by the square root of the sample size. The population standard deviation is 24. The sample size is 100. If you do the calculation, you get 2.4. Alrighty. Part B. Part B says describe the shape of the sampling distribution of x bar. Again, using the central limit theorem, we know that if n is greater than or equal to 30, if the sample size is greater than or equal to 30, that the sampling distribution of x bar is going to be approximately normal. Okay. We can actually draw it. It's going to look something like this. So this is the sampling distribution of x bar. So the value that's in the middle we know is the mean. In this case, the mean is going to be 29. Okay. The standard deviation over here is going to dictate how wide this distribution is. All right. So again, we can use this mean and this standard deviation to use the empirical rule. For example, we know that the amount of area under the curve between 26.6 and 31.4, which is the mean minus 1 standard deviation and the mean plus 1 standard deviation, should be approximately 68%. So 68% of the area under the curve should be between here and there. We know that using the empirical rule and using this information we have from Part A. Okay. So let's go to Part C. I find it very helpful when trying to solve problems like C, D, E, and F to draw a picture. So what I'm going to do here is I'm going to draw a picture of the sampling distribution of x bar. We know the mean is 29. Right? We know the mean is in the middle. And again, we know that if we go out a certain number of standard deviations, then we're going to get pictures that look like Part B. What I want to do here is I want to see if I can shade the region under the distribution, the sampling distribution for x bar that I've drawn. Okay, just right there. So what I'm looking for, again, this is a picture of x bar, right? I'm looking for how much area is in the shaded region here. Okay, how much of the area is in the shaded region there? Well, if you look at that, you'll notice that it should be at least 0.5 or 50% of the area, because we know that 50% of the area is to the right of the mean. So whatever value we get for this problem, we know that the answer has to be greater than 0.5. So when we calculate this value, we know that it has to be greater than 0.5. If we get a value that's less than 0.5, we know that we made a mistake, and we should go back and rework the problem. Now, if you look at this, it's hard to figure out how much area is underneath the curve or is shaded. So what we have to do is we want to convert this problem to a problem that involves a z-value. So what we want to do is we want to convert the x bar value to a z-value. Okay. We could do that using what's called the z-score. So we want to calculate the z-score for 28. We do that simply by using this formula. Right? So we take the value that I'm interested in, which in this case is 28. I subtract the mean, which is 29, and I divide by the standard deviation, which is 2.4. And if I do that calculation, I get a value which is approximately minus 0.4167. So the way to think about this is that I'm going to convert this problem in the x world to a problem in the z world. I'm interested in the x bar world, knowing how much area is to the right of 28. Okay. In the z world, I'm interested in knowing how much area is to the right of minus 0.4167. So this problem here is equivalent to solving the problem z greater than or equal to minus 0.4167. Okay. Now to determine this, I have to look at my picture over here. All right. The area to the right of this value right here, I can think of the area between there and there. And since it's symmetric, right? Since it's symmetric, it's the same area that's between there and there. So these areas are the same. So I know that this is equal to probability that z is between 0 and 0.4167. Okay. Plus, so again, I've taken the area here, and I want to add it to the area that's to the right of 29 in the x bar world, or 0 in the z world. So it's going to be plus 0.500. Now this value you can pull out of the table. What you're going to have to do is you're going to have to approximate this. So what we're going to do is we're going to go to the table, the z table, and look for 0.42. Okay. If you look at 0.42 in the z table, you're going to get a value which is 0.1628. Then we're going to add the 0.5, which we have here, and that gives us as a final answer. Erase some of this. Okay. Going to give me 0.6628, which is the answer that I'm interested in. So what this tells me is that if I draw a random sample of size 100 from this population, okay, the probability that the mean of that sample will be greater than 28 is approximately 0.6628.